her attention. Thanks.
Good afternoon, ladies and gentlemen. My name is Joye. I'm a computer science major from the College of Charleston, and I am doing research in Dr. Kalidindi's Materials Science Lab. Together, me and Dr. Tony Fast have created a mobile application that's going to be used to track metadata in material science experiments. And we are really excited about this product, so I'm going to go ahead and get started. So, first thing you're probably thinking is, okay, it's the mobile app, that's cool, but why do we need this for the material science world? Well, in the material science community, it takes approximately 20 years to incorporate newly developed advanced materials into commercial products. Now, this is far too long and too slow of a pace to address the urgent challenges in our society today. Advanced materials are essential in economic stability and human well-being. They can be used to solve great issues like developing new technologies for clean energy, economic welfare, and human welfare. Fortunately, in June 2011, the White House released the Materials Genome Initiative. The Materials Genome Initiative is the goal of the Materials Genome Initiative is to issue in a new era of materials innovation that will deploy advanced materials at half the speed and a fraction of the cost. Now, it is believed that with advances in computational techniques and enhanced data management, that we can expedite the process that materials are being incorporated into commercial products today. So, with that being said, we want to look at what our material science community is doing to collect information, because this is important. And we need to know how information is being collected in order to speed up this process. So, in the material science community, our technology for collecting data is simply lab notebooks. It's always good to have a pen and paper, but there are many issues with lab notebooks. They're often illegible, poorly annotated, and forgotten. Most of all lab notebooks are unsearchable. The theory behind this project is that the future of the material science community is going to be data-driven. What this means is that we cannot get the information out of these notebooks because you can't search them. So we want to create an application that will store this information into a database so we can collect it and access it for use in developing new advanced materials. So our model is a user interaction-based one, which is basically saying that we want you to use your application as your lab notebook. And this application is going to create an infrastructure that stores all of your material science experimental data into a database that we can access and use for creating new materials and speeding up the process. Now, this is a novel idea to the material science community, but it is comparable to the medical field. And this is shown in electronic medical records and electronic health records that track a patient's health care along their lifetimes. So, without further ado, ladies and gentlemen, our product is called Materials Laboratory Transactions, or MaLT for short. During the first iteration of our product, which we finally completed on Tuesday, we have a minimum viable product that actually can test tracking material science experimental data and collecting it into a database. So these are the tools that I use to create the application. First off, and probably most importantly, we use the Eclipse Integrated Developmental Environment, which we coded in Java with using the Android application development tool. Also, another crucial aspect of our application was definitely the user design. So we designed all the images and layouts in the Google Drive drawing tool. Google Drive was really good in enabling collaboration between me and Dr. Tony, and it also allowed us to create the images that we want to use. Next, we used a SQLite database to create our first sample database that will store the metadata that we collect in our experiments. Along with that, we developed on 2 Android devices, 1 tablet, and an S3 Android phone. Lastly, at the heart of our application are QR codes, which I am going to talk about a little bit soon. Sorry about that. Okay, so let's break down this application. What you see here is the actual main menu for the MaLT application. It has 3 main functionalities: register, record, and review. So the first functionality that a user will have to go through in using this application is the register process. So as I talked about earlier, these are the QR codes, these black and white squares. So what the register process does is actually enable the user to associate the QR code with either a sample or a piece of equipment. So when you use the application, you simply hit register and you register a sample or a piece of equipment to a QR code. Now this makes it easy to facilitate the tracking process, which I'm going to talk about next. So after registering, you can actually record experiments. Now this functionality allows you to actually track the experimental process that you do, and a user simply opens up the application, hits record, and scans in the QR codes used in experiments. So let's say you use the scanning electron microscope. You're going to scan in that QR code, and you're going to scan in all the samples used in that experiment. After you do that, then you're taken to a screen that looks like this. This is actually the register data collection screen. But you're taken to a screen that looks like this, and you're asked to enter comments and add pictures. So this is an easy process that allows you to record all the information that you just collected from your experiment in an easy manner. Lastly, our application includes a review functionality. Review is used to actually look at all the experiments that you've taken place with the application. So this is actually a database table that I'm going to show you later on. So in order to test this application, we created 2 user cases. One user case was based on a tutorial functionality that we think MaLT will be successful with, and the other was based on a typical procedure that would go on in the lab. We didn't actually modify actual samples, but we did create an experiment based on paper samples and actually testing with actual equipment QR codes in the lab. So this is a diagram showing our case studies. As you can see here, in the theoretical user case, the tutorial went through this process and recorded notes in the application. So after they finished their process, then they simply told the student to look in the MaLT database and read the notes for a tutorial. So the student was able to actually go through the experiment and the training processes using the MaLT notes and application data. On the left side of the screen, you see a typical procedure that might go on with an experiment. So the sample is split into 2 other samples, as you can see from the original, and it's shipped to a contact. The contact performs the actions that it wants to perform on the sample, and it ships it back, and we get that data in our database. And we are able to add extra experiments, as you can see here. So this is actually what the review screen looks like in the application. Zoom in. If you go to the view and edit functions, you can actually see more metadata information that we collect via the experiment, but this is just the front page of the review screen. So as you can see here, the first half of the experiment review screen just shows the tutorial process that we went through. Second half is the trainees actual testing the equipment, and this is the typical procedures that we recorded. Using this application, we found some negatives. With the application, we mapped the sample QR codes to the samples using this. So the samples will be starting here, and the QR codes will be placed on the top. So as you can see, we will place the QR codes alternately on the box. And what this presented an error with was the camera affordance. So it's awkward because you couldn't go straight to a QR code. You would have to actually move the camera around. So that presented a kind of issue. Also, there is no actual link to the original billet in our database. I don't know if y'all remember from the diagram I showed you earlier. There is actually an original billet that was shown, and we don't have a link to that in our database yet, and we want to get that fixed. But other than that, there are a number of positives with our MaLT application. It is quick and hassle-free. The user is able to record information about their experiment easily by just scanning QR codes and entering user comments. Also, another feature of our application is that you can add the metadata at any time, so it doesn't present an inconvenience because you can always go back and add it later. And lastly, we love that the review screen added organized results for the user to view later. With that being said, there's always more work to be done. In the future, we hope to make minor modifications. One of the biggest minor modifications we want to make are additional queries in our review screen. So we want to add, so the user can view a specific sample or a specific piece of equipment and actually refine their review screen results. Bigger goals, we would like to centralize all of our data in one big community database in the future, so we can actually fulfill the goals of the MGI by creating an infrastructure that will allow people to actually access data that is being collected from the material science experimentalists and actually get those materials out faster. Lastly, for future applications, okay, quick poll, who has actually been to the CRC? Okay, that's good. So you see at the CRC, the equipment has QR codes, right? So what if we could create an application that scanned in the QR codes and track your exercise progress? So that's just an idea. So I would like to thank Dr. Kalidindi for letting me work in his lab this summer, Dr. Tony Fast for being such a great advisor and mentor, and the SURE program for one of the best learning experiences I have ever had in my life. Thank you so much.